Okay guys, lesson 4 here on sampling. I apologize for the lighting and it's late at night and I gotta do what I gotta do because I want to get this lesson up for you guys. So sampling, this is very important because in almost any study that you do you're gonna have to sample, and we'll talk about what that means and how to go about sampling. So some definitions at the start. Um, a population is a group or class of subjects, variables, concepts, or phenomena. So think about whenever you want to study something. Let's say you want to study the opinion of people in Alabama. Your population, in that case, is Alabamians, people in Alabama, right? If you want to study the opinions of Americans, then your population is Americans. If you want to study the opinions of UNA students, then your population is UNA students, right? If you want to study 2014 articles published in the New York Times in 2014, then your population is all of the articles that were published in the New York Times in 2014. Okay, so that's your population. Now, usually we can't study every member or item in the population. We just can't. We don't have the time. We don't have the resources. And the beautiful thing about statistics, we don't have to. If we take a sample, and if it's done right, if it's a random sample, then we can represent the larger the population, even with a sample. So it's almost just as good as studying every single member. When we are able to study every single member um, or item in a population, that's called a census. Okay, but again, we're not able to take censuses very often. When they talk about the approval rating, you hear this in the news, right? President Obama's approval rating is whatever, 49% or whatever it is. Um, that's based on a sample. They didn't go around and ask every single American what they think of President Obama's performance, right? They took a sample, which is a subset of the population that is representative of the entire population. Representativeness is the key here. If a sample is not representative, then it's inadequate for testing. But if it is representative, then it's just a beautiful thing. And you saved all that time, you saved all that energy, all that money that you would have had to spend, taking a census, right? Which can be really tedious and laborious, and in some cases just impossible. I mean, it would not even be possible to survey every adult American. I mean, I don't even think that would be physically, humanly possible. I mean, there are people who are not going to be accessible, right? You're not going to be able to get a hold of them. So anyways, um, a good sample, if you are able to take a good sample, if you take a random sample, randomization is really important. We'll talk about it. Then that means your study is generalizable. You're able to generalize to the larger population. You have representativeness. You have good external validity, right? But I want to be clear. Samples are really, really good, but they're not 100% perfect. In other words, there's always going to be a little bit of error. Okay, so if you think of two scenarios, let's just stick with that example of UNA students. Let's say you want to find out what UNA students think about something, right? Um, you could take a census. You could go around to every single UNA student. I think there are like 7,000 students. The number that you would get, let's say it's 60% of the students think that the facilities at UNA are of high quality, if that's what you were doing a survey on. That would be the real number. I mean, that's it. It doesn't get any realer than that because you asked everybody. 60% exactly feel that way, right? If you took a random sample, you could get really close to the real number, right? The census figure, the 60%, but it might not be exact. There's going to be a little bit of error there, okay? And that's something that I think you need to be aware of. this issue of sampling error, and we have to take that into account. And that the formal definition is the degree to which measurements of the units or subjects selected differ from those of the population as a whole. So it's the difference between the sample and what you would have gotten if you did a census, basically. And there's a way to calculate this. We're not going to calculate it in this class, but it can be done with statistics, okay? This is just an example of how careful a person has to be with error. During the 1936 presidential election, there was a publication called Literary Digest, and they predicted Landon was going to win the election over Roosevelt. And they had a large sample, but their sample was not random, and it was not representative of the American population. They basically talked to a bunch of wealthy Republicans. So there was a large degree of sampling error, but they didn't take that into account, and they lost a lot of credibility, right, when they predicted that Landon was going to win, because Roosevelt ended up winning. They ended up shutting down Literary Digest, I think 2 or 3 years after that election season. So there are two kinds of sampling that we want to look at: probability sampling and non-probability sampling. All things being equal, we want to choose probability sampling whenever we can, okay? Because it involves random sampling, where every unit in the population has an equal chance of being selected. So what you do essentially is, if you want to think about it as, you put a bunch of numbers in a hat and then you draw the numbers out randomly. That's kind of what you're doing, right? I mean, now we use like random number generators. We don't actually draw numbers out of a hat, but you can do this, by the way. You can visit the website random.org, random.org. You can do that right now. I mean, you could pause this and go do that and play around with it. Take some random samples. It's pretty self-explanatory, pretty easy to use. The great thing about probability sampling, it's representative, right, of the population, right? It involves random sampling, and you can calculate the amount of sampling error. With non-probability sampling, we are not employing random sampling techniques, and we can't calculate sampling error. So again, you always want to choose probability sampling if possible, but sometimes it's just not possible. In some cases, you just have to make do with non-probability sampling techniques, and you have to try to, and there are ways that you can kind of mitigate the disadvantages, and you can compensate and still produce a pretty good study. There are a lot of studies out there. I've published I think 1 or 2 studies that employed non-probability sampling techniques where I just could not get a list. Like when I was in Egypt, I could not get a list of all the journalists to kind of draw out of a hat. Basically, I couldn't do it. So I tried my best to mitigate the problems, and I think I did a pretty good job of that. In any case, so sometimes non-probability sampling is inevitable, but if you have a choice, choose probability sampling. There are different kinds of probability sampling techniques. There's the simple random sample, where every unit has an equal chance of selection, as I mentioned. You're just kind of drawing numbers out of a hat, or you use a random number generator or whatever. There's also systematic random sampling. So if you know, first of all, the size of the population exactly, and if you also know how many, how big of a sample you want, then you can do this systematic random sampling, where you're selecting every nth item, like every 5th or every 10th or whatever. So let's say you know that there are 7,000 UNA students, and let's say you want a sample with, you want 500 you want to survey 500 students. Then you could select I guess that would be every 14th UNA student, basically. Okay. So you have simple random sampling, systematic random sampling. You also have stratified sampling. This is where you divide the population into groups, and then you randomly select a sufficient proportion from each group. They do this a lot with geography. So they'll take Alabama, for instance, and instead of trying to take a random sample of Alabamians, that can be difficult. You might end up getting with a disproportionate amount of, everyone was from Birmingham or Montgomery or Huntsville, the bigger cities. But what about people who live in the smaller cities? What about people who live in Coleman, Alabama, or something like that, right? So what they do is they'll divide Alabama up into groups, into little regions, like maybe by county, for instance. And then they'll randomly select a sufficient proportion from each county. That way you ensure that you're getting a little bit of everything, right? So sometimes stratified sampling is the more appropriate option. But again, this is a probability sampling technique. It involves random sampling, so and it's very strong. Cluster sampling is similar. You divide the population into groups, but then instead of selecting a proportion from each group, what you do is you just randomly select groups. And sometimes that's in certain cases that's the most appropriate thing to do. Okay, so those are 4 kinds of probability sampling techniques. You also have a number of non-probability sampling techniques. You have the convenience sample, just whoever's available. Hey, you over there, come and participate in my survey. Sometimes that's all you got. That's all you have, and you just have to make do with that. Just whatever's available, whoever's convenient, right? Um, whatever people you can get a hold of, whatever articles you can get a hold of to analyze, whatever. Um, Volunteer sampling. This is another common, people that are doing surveys, right? Ask people to volunteer. You've probably gotten emails before asking you to volunteer. Please fill out my survey, right? But again, it's not perfect. This is not the ideal way to go about things because people who volunteer for something are different from those who don't. So you end up saying something about the people who volunteered, but not necessarily about the population as a whole. You see what I'm saying? So again, that's a problem with non-probability sampling techniques like convenience sampling or volunteer sampling. If that's all you got and that's what you have to make do with, you have to make do with it. But if at all possible, use the probability sampling techniques. There's also purposive sampling, which is when you select elements for specific reasons, right? I'm going to select this particular set of newspaper articles because they directly address what I want to study, for instance. This is common in advertising when researchers want, for example, to study people who use a specific product type. Right? I only want to study people who use Dove soap. That's all I want to study. So I use this purposive sampling technique. There's also quota sampling. This is when you select subjects based on a predetermined percentage. So let's say, for example, I'm just making these numbers up, but let's just say, for example, that we know that there are 45% of Americans who support Democrats, 45% who support Republicans, and 10% who are kind of, independents or on the fence. We might seek a sample that reflects those numbers, right? We want 45. We want our sample to look like that: 45% Democrat, 45% Republican, 10% independent or other or on the fence or whatever. But this is, even if we take a large sample, this is still non-probability. It's not truly random. Okay. And then there's the old snowball sampling technique, where you just can't get a hold of the people. Usually this is with people, right? But well, it would always be with people. You just can't get a hold of the population. So what you do is you find a few people that you can get a hold of, and you ask them to help you. You're like, hey, do you know somebody who has similar interests or who would be qualified to participate in this study? And you let it snowball like that. Okay. Note, some students think that if I take a huge sample, then that'd be great, and it's just like a random sample. No, it's still a convenience sample. It's still a non-probability sampling technique. There are 7,000 UNA students. Even if I took, let's say, in the hard sciences, I'm just making this up, but let's say that 5,000 out of the 7,000 students are in the hard sciences, like chemistry and biology. They're all over in the science building taking their classes. 5,000 students out of the 7,000. Even if I surveyed all of those students, all 5,000 of them, and I had this massive sample. I mean, a sample of 5,000 for a population of 7,000, that is massive. But I still could not say that that's a random sample, and it still would not be representative of UNA students because I only took the science students. I haven't even spoken with or surveyed the sociology students or the psychology students or the mass comms, the communication students, right? So you have to be very careful about that. A large sample does not necessarily mean that you've transcended, randomness. You haven't. And that's it. As promised, lessons 3 and 4 were pretty simple and straightforward. Make sure you're doing the readings. If you have questions on this or anything else, let me know. In the next few days, I'll post lesson 5. That'll be the last lesson before the midterm. Let's see if I can figure out how to stop the recording.